I am going to skip past the obligatory legal notices and agenda and get to the meat of the matter right away. First off and foremost, I really am an engineer. I don't really dress like this on normal days. So don't get the idea that what we're going to do here is talk about Intel stuff. I'm actually going to talk about what I, as an Intel engineer, do in the area of virtualization and workspace portability. So we are a portion of Intel that does the engineering and makes things work. A part of it, of what we're doing, is our Intel IT labs. They basically go out and do pathfinding, do discovery about what is out there in the environment, what's coming out 5 years from now, and things like that, and start looking at the vendors that are going to be able to provide those products. So they get them in as quickly as possible, they test them all out, and they give good recommendations on what works, what doesn't, and move forward from there. And then they also, of course, use Intel capabilities to make those things better and figure out how Intel can improve our products to encompass all of the virtualization strategies and things that are out there. I am an Intel engineering. I'm a staff engineer on our client platform services team. What my job is to take a look at those new technologies that come to us from pathfinding and figure out how those integrate into a production environment. Those guys in pathfinding get to play in an imaginary world in labs and things like that, and then they say, here's some good stuff, and we bring it into the Intel environment where things are very different. I'm sure in your Active Directory environment, things are very different than in a lab world as well. We have multi-tiered AD and all this sort of fun stuff that we get to deal with. Our rights are locked down, so we have to use special ways of getting accounts created and OUs and all that. So we figure all that out, and then we figure out what the service deployment architecture is going to be able to bring this stuff to production. So that's what the IT engineering side of things does, and then I'll let Ryan talk a little bit about what they do.
My name is Ryan Edel. I actually was in IT for 7 years, then I moved over to this group. It's called Intel Architecture and Systems Integration Team. I'm actually part of the playground, the pathfinding, the get to play in the lab most of the time. And every once in a while we step out and we do early adopter, POC type work. And then scale enablement and basically educating all the different business groups at Intel about different desktop virtualization technologies. We also host several, probably 20 or 30 customer visits per year, discussing the technology.
So the kind of things that we focus on, operating system virtualization is one of them, and we've been doing that for a while. We also look at app virtualization, and more we're looking at data virtualization and content synchronization. We'll talk a little bit more about that. We also look at how we can modify the access of things you have that you can get to based on a trust level. And then, of course, we're concentrating a lot on Ultrabooks in the enterprise. We like Ultrabooks as much as most everybody else does. I have one. I love it. But there's capabilities in an enterprise that some of the features in Ultrabooks can make challenging. So we look at those sorts of things. And of course, a big concentration on consumerization and bring your own. We have a full team that is dedicated to just BYO for IT engineering. A little bit about our TAM and the groups we work with. We have about 105,000 PCs. The vast majority of those are laptops. We also have about 28,500 as of last count smartphones in our environment, and 58% of those are BYO devices. So we encompassed, we embraced BYO for the smartphone environment quite a while ago, and have let those come in and given more and more access as capabilities have improved. And we also have about 2,000 tablets already enabled in the environment. Getting an iPad into the environment was fairly easy because we'd already done the iPhone. So that made it really simple. So what I want to talk about first is some of the emerging trends and their influence on enterprise IT and what we're kind of dealing with. So this is a little thing about the day in the life of a corporate user, and we had a bunch of engineering geeks come up with this, but it's a pretty graph, and it really does a good job of explaining how things have changed. I mean, it used to be, if you look at the yellow graph, you'd kind of come into work and you'd be on your work environment from 9 to 5, and then you'd go home and you'd be away from it. And that has changed significantly to now you're getting constant interrupts in both directions as you go throughout the day, and you've really blended your work and your home life to a great extent. And so what we're trying to do here with our programs is to make it so that you can do that as smoothly as possible and as easily as possible. So our business, the client platform that I work in, is really becoming more and more complex and more costly to manage. I've heard it said many times at this conference so far that BYO doesn't have an ROI, but it's something that we need to do. It's something that that if we don't do it, we're going to be in trouble. But consumerization, all these multiple operating systems, multiple vendors dealing with all that, and really the big one is the one-to-many ratio that is driving our strategies now. We've got a single user that has multiple devices. We have also many-to-one ratios and things like that to work with. The other one is that the users really are demanding, and they expect to have access to the corporate environment. They want to be able to do that from whatever devices that they bring in, whether they own it, whether we own it. This is actually becoming more and more important in order to keep and retain employees and also to recruit employees. Technology industry really depends on the talent that they continue to bring in. We want to make sure that we can attract that talent, and having a good BYO program, I think, is very important to being able to do that because it's an expectation. We obviously are going to require scalable solutions to manage that complexity, and we have to have solutions that can maybe start out small but be able to grow big. And so even as we design these small systems, we have to design them in such a way that we know that they can expand. There's also this fundamental shift in how we manage that client endpoint. So we're going from controlling the whole device, PC-centric model, to really controlling the containers of the different capabilities that are on there, the applications, the content, and all those sorts of things. And it's going to be it's going to be a combination of a bunch of different things. The device itself and the capabilities of the device, how much bandwidth you have, and the usage model, and of course policies, and those all kind of come into play. So what we have to do is we have to balance the security requirements that are increased, the cost that's increased, and the manageability the manageability problems that have increased. And we also have to take a look at those and get those working, but we also have to keep in mind the privacy and above all the user experience. We're concentrating very heavily now on the user experience, and we're finding that people want BYO, but they don't want BYO to be as kludgy as we've made it. They don't like it, complicated logins and all those other things that are required to get it to work. So there's that tension between the users and the IT department, right? The user wants that freedom. They want to be able to access stuff anywhere, anytime, and they don't care what device it is. And it's that Generation Y mentality. And of course, IT still wants to hold on to everything, and especially the security department wants to make sure that our content is secure. Did you have a question in the back?
Does BYO just mean I want to use a Mac, or does it also mean I want to use an iPad? I mean, it's a new call it.
BYO means
I want to Windows PC to work. That's the question.
BYO to us means I want to use whatever, whether it is.
I know it's expedient to say that, but I'm trying to get precision. I'm trying to gauge what I'm really after is what are people really doing.
So we've had a BYO Mac program for about 3 years, and as of a year and a half ago, initially it was BYO in that it was a company purchased device, but it was still set up as a BYO. As of a year and a half ago, we allow people to actually bring their own. We've had BYO for Android, iPhone, iPad, all of those for varying numbers of years already. We are currently in the process of looking at BYO PC, which is much more complicated. So BYO really for us means anything you want, that we can get past all the controls that we have in place.
Thank you.
Yeah. So speaking of the controls, we're looking to control the network access, control the operating system, and of course the data security is one of the key ones. And we have to have predictable configuration, so we have to know when a user connects that they've got those security considerations in place, and so we have tools that are there to make sure that that happens. That's where BYOPC becomes more complicated, because you're talking about maybe a Windows OS on a Windows OS, and there's security concerns about that are different than the security concerns of accessing resources on a non-Windows OS. So it makes it different. The impact on the client computing is that the user is really driving IT. As I was saying there, we want them to be able to bring anything. Actually, we'd love it if they just use our laptops, but they don't want that. So that they're going to bring everything. We have increasing security and regulatory compliance, and privacy requirements actually is the one that tends to sneak up on you. There's a lot of things about privacy, especially in the EU, that have to be taken into consideration when you start looking at virtualization, start looking at delivering content to devices that you don't own that may have personally identifiable information on them and things like that. You may be gathering information about a user's PC that they own personally that contains their username in it, and you store it in a database because you've got that asset you want to track. You store that in a database. Well, you have to be able to purge that from that database after the user leaves the company. Otherwise, it's a personal information violation. And there's really complicated things like that you deal with BYO. So there's those kinds of impacts. There's this going from 1-to-1 ratios to 1-to-many ratio. As you go from 1 to many, users want to be able to get at their information on all the devices that they have, and so we have to have strategies to do that. We also have those user-owned devices in the enterprise, and you think, okay, it's BYO. If we want to, we can just join their machine to the domain, and then we can put our security suite on them, and they're good to go. Well, that's great until they want to leave the company, and then you have to remove all the security suite. You have to remove all the applications that got installed, and then you have to unjoin it from the domain. But even after you've done that, you've already replaced the Gina, and you can't get the original Gina back, so that they don't have to log into their machine. So they'll always have to hit the Control-Alt-Delete and do things like that unless they get in there and start hacking with it. So there's that whole thing about user-owned devices and getting those in the enterprise. Users expect to be always on and always connected. So we look at, when we look at VDI is very much designed as a connected model. So when we have scenarios where the users want to be offline, that comes into consideration. They may not be a good candidate for using a VDI environment. In addition to that, they still want great performance, and so you have to balance the cost of putting virtualization onto an endpoint, such as using a Type 1 or a Type 2 hypervisor, the impact of on the performance of that device, and they always want that. And of course, you look at how you're going to deliver, say, applications in a virtualized way. You need to have good performance there as well, or the users won't be happy. They also have to be very easy to use, including the security controls. If you get a user frustrated just trying to get at what they're trying to get to, then your program is going to be unsuccessful. So we use client virtualization as an enabler. It is not the ultimate solution to everything. It's an enabler for us to be able to deliver these solutions. And what we're trying to do here is we're trying to abstract the components. We're not just talking about operating system virtualization. We're trying to abstract all the components that delivers a user workspace, and that allows us to do a lot of things, fast turnaround time on repairs. So for example, if your content is in the cloud and your apps are virtualized and all that stuff, if a user wants to get a new PC, you give it to them, they turn it on, and all of their stuff is going to sync to them automatically in the background. So you get them back up and running very fast. and they are not losing all their productivity in reconfiguring their applications and in resetting the way that that their desktop looks and all that other stuff. So we look at how fast we can turn around that. In some companies, that might not be as big a deal because your people maybe don't get high wages. When we get Intel engineers that are down, the downtime impact is very big because they are not cheap labor. We also are looking at greater flexibility and faster solution development at a lower cost. And not all of this stuff is ROI, but there are some things that we really benefit from in looking at this componentizing of this stuff. And then, of course, we get increased granularity control. So that gives us a better security posture. It allows us to control it while still giving the user a great user experience. So the way we do this is by what we call a virtual workspace. So we've got these virtual containers that form this workspace, and that's really the ultimate direction that we're going towards. We're basically making that user environment available on multiple form factors. Obviously, not all the components of the workspace that you'd see in a Windows world are going to be available on your non-Windows devices. We're only going to deliver what's appropriate for that device. And so that environment is created dynamically based on the device capabilities and the security context. So first we'll talk a little bit about the device capabilities. And this is where we break down the client workspace. So what we're trying to do here is we're trying to deliver all of these components of it independently. In the mail world, one of the biggest issues that has gone on in terms of being able to get users portable is everyone has a PST. And everybody has to use their PST and they have to be able to access it. And I don't know if you've ever tried to access a PST across any sort of share of any kind at all, but it just doesn't work. Don't try it. And so that PST is really not portable at all. It really needs to be tied to one machine. So what we're looking at, we have to look at ways of making that better. And then the next one is the applications. And getting those applications delivered in such a way that they're available, right? Whether it's virtualized on a server or whether it's delivered as a virtual container to the client, all depends on what the use case is and if the user is mobile and all those sorts of things. So we have to make those decisions based on all those criteria. And then we have business data and non-business data. And we call this non-business data rather than personal data. And the reason that we do that is because personal data, some people like in the privacy world, consider data that is about the person. And so they think, oh, personal data is something that you don't want to have anywhere on your machine, right? So we call it non-business data. It's still all the things we think about. It's your music, it's your pictures, it's all that kind of stuff. But we call it non-business. So we have to separate business and non-business data, and I think in many environments those two things are not separated right now. People have combined them pretty well. If you give your users any sort of rights on their PCs, then they're well combined. So we need to look at how we can create tools to separate those out so that we can start putting them in the right location. We don't want non-business data to be stored on Intel servers if we're backing it up or anything like that. We only want the business data there, and so we have to look at how to separate those two well. And then there's personalization. Personalization you think of as the desktop, and people think, well, great, if I could get my desktop to look the same on my old machine and new machine, then or my two PCs or my PC and my tablet, then that's great. But it's really a lot more than that. It's your signatures in Outlook. It's the way that you sort your files. It's whether you show hidden files and folders. It's all of those little tweaks that you do when you get a new PC that take a lot of time. And so if we can capture all that information and deliver that to a new desktop or to multiple machines at the same time so that you've got that consistent across all yours, then we think that that's a big win. And all of those things combine to give us the client workspace. And then we deliver that workspace to the device that we want it to go to. So benefits, there's benefits all around. The first benefit is, of course, it allows better manageability and security of the service. So we can take, for example, one particular service that is, say, the user personalization. And we're only going to deliver that to Windows PCs because that's really what it's for. Well, we may not have to send that, get that through the firewall. We can just deliver that internally while you're on the Intel network. So we can do that that way, and we don't have to have nearly as big an infrastructure to do that. So we keep that separate from the other things that we're doing. So we can manage it on its own, and we can keep it more secure because it doesn't go out through the firewall. And on all these sorts of things are updated centrally and then pushed to the endpoints so that we get that centralized management, makes it much easier to do. We also allow an optimized user experience by just storing things centrally but executing them on the endpoints. So the way that we think about it is that a PC really does have very good performance, and you want to have your execution going on the PC. It just works so much better in our experience. And so even though we're looking at centralizing this stuff, we're not actually looking to do the execution centrally. We're looking to do the execution on those endpoints. And doing all this, the other big benefit, of course, is it allows that any user-to-device ratio. We've actually got situations, say, for example, for our fab workers. Well, when they go on break, they go en masse, and they go into these things that used to be called bullpens. And so they would log on to any one of those PCs. Whichever one was open, they could log on and they could do their work or check their mail or whatever it is. Things they can't do in the fab because it's a clean room environment. They can't do any of that stuff while they're in there. And so that is actually a many-to-many ratio, where you have many users that can log on to any of multiple PCs. So virtualization actually is a big play in that area to be able to enable that. And then, of course, we have the one-to-many, which is really what a lot is going on now today, with users having multiple devices. I think I probably have 10 of various sorts. So the impact of virtualization on IT is pretty big. Obviously, it enables that device-independent mobility, and that's the way we look at it, is that we don't really care about the device anymore. We care about what you're doing on the device. We get the device ratio going from one to many, and really it reduces the footprint that IT has to manage. If we can update an image centrally and push it out, or update an application package centrally and push it out to the multiple endpoints, that's a huge win for us, and it really reduces our footprint. Because pushing, say, an update to an application out to 100,000 endpoints is problematic, especially when a lot of them don't necessarily connect to the network on a regular basis. You got people connecting over very slow WAN links and things like that. We want to manage those containers like appliances. In other words, they're independent capabilities that we put together to deliver that workspace. The other impact, obviously, is it enables user choice. So as I was saying, we've had a BYO Mac program for a while. If a user wants to bring in a Mac, they absolutely can. And whereas initially that started out basically being a Mac that was on our network that had parallels running on it so that they could run their Windows stuff, which is where they did all their work. That's evolved over time to where now the parallels is on there as a backup, but almost everything they do in the native Mac environment. So it evolves through time. So you can use virtualization to get started down the path of BYO, and then as time goes on, you develop those applications that are more native to the device that you're on. This also allows us to seamlessly enable new technologies. So if we've got something new that's out there, we can actually deliver it through virtualization, and then start working on a better way to do it. So for example, if we need to deliver a web-based app and it only works on IE8, it doesn't work on IE10 now, and we want to put out Windows 8. Well, we can deliver that, say, through a virtualized application, and then go back and fix the application so that it works on IE10. So it allows us to get those new technologies going while still having the way to deliver the old stuff if necessary. And of course, it enhances security controls. So I want to talk a little bit now about about security and how we see security in this environment. This is where it gets fun. So we think about trust levels when we talk about security. And this was actually a really large program at Intel that came up with the model that we're talking about here. And there's a lot going on, and will probably be going on over the next few years to really start bringing this model to fruition. But the concept is pretty solid now. And what we talk about is defining trust levels. And so we go from trust level 0 to trust level 4. Trust level 0 this is somebody else's device, right? You might be in an internet cafe where you're worried about screen scrapers and keyloggers, and you don't want that device to be able to access any of your stuff. So that is trust level 0, right? And then you kind of go up through here, and you go basically, as you go up the stack to trust level 4, you have less personal management, personal ownership, and you move to more corporate owned and corporate managed. At the very top is the traditional PC that's corporately owned, that's corporately managed, that's fully trusted on our network and all that other stuff. So we define these trust levels, and those trust levels can be defined based on the device that you're on who you are, on where you are, and it combines all those to determine your trust level.
Is that a dynamic?
Yes. Yeah, it's dynamic. So for example, if I am at my house and I connect with a device that trusts me and trusts my device, and now it trusts my location too, because I'm in the U.S. Well, if I am on that same device and I'm the same me, but I'm connecting from, say, a controlled country where the networking is not necessarily as secure, I might not get as much access. And it sounds really simple. It's not easy to do. So there's a lot of work that's going on to make this happen. But this is the concept of it, right? At trust level 1, so for example, when we first brought iPhones into our enterprise, at trust level 1, we allowed calendar contacts and email. But because we didn't trust the security of that device at that point, because of the operating system that was on it, we didn't deliver attachments to that email. We used another product. If somebody had a need for attachments, we found another product that they would have to install. It was more complex to use, but then they could get attachments to it. Once the capabilities of the iPhone included the security level that we needed, then we allowed attachments. And so now anybody at Intel can sign up their iPhone and they can get calendar, mail, contacts with attachments. All that stuff is there. So that's trust level 1. And trust level 1 doesn't really have a lot of controls on it. You have to secure your device with a password and some things like that, but it doesn't. You don't have to VPN in and do all those complicated things to get in. As we move then up to trust level 2 and trust level 3, we're able to deliver more and more applications. We will use, say, mobile device management to deliver some additional applications that contain various levels of confidentiality. And then, of course, at trust level 4, you can deliver the whole suite of applications and anything that you want. So we use this model to figure out what we're going to deliver and to whom we're going to deliver it. So I want to talk now about user experience across those devices. So as we look at users to be truly mobile across those devices, we're looking for a consistent and ideally native experience across the devices. So consistent is one thing. If I can deliver an application through a terminal services capability with XenApp or whatever, that's good, and that is consistent across all your devices because you're still going to use, say, a Citrix receiver to get at it. But it's not necessarily a good experience compared to running an app natively. And so we look for that native user experience through time. Again, it's a capability that we deliver as the technology evolves. And then, of course, we enable application access based on the device capabilities, too. We need to be able to get at those applications. If it's an application that can run natively, then we'll do that. And we dynamically build the workspace based on the trust model. So, for example, if you're on a device that is not secure, we're not going to give you any content. If you've got that device and you've logged in with a VPN or something like that, well, maybe now we trust you enough to give you the content that you were looking for. And we need to provide complementary tool sets. What this means is that we need to be able to get the user into this environment without having to make them go through a whole bunch of work. So for example, right now, I talked earlier about how we have the business data and the non-business data and how it's all mixed together. Well, we actually have our engineers writing a tool right now that will go through and do some basic analysis of what's in my documents and split it out and split it into a business folder and a non-business folder. We think that is the first step to getting the user to be able to sync the business content on the internal cloud and sync their personal content to some external cloud of their choosing. So we have to have those tool sets to make this conversion very simple. So some of the things that we're doing, and these are real projects here. Type 2 hypervisors. So we currently have in production Type 2 hypervisor environment for our mergers and acquisitions department. This allows the mergers and acquisitions people to go out into the field, and on day one of that acquisition, they can take our build on a USB stick, plug it in, turn it on, and they have a complete Intel environment on that USB stick. And then the acquisition can continue to do their work on their device. They can continue to do Intel work on Intel devices. They're completely separate and isolated. We can decide by policy whether we want to allow copies and pastes between them and all those sorts of things. And that's something that we do depending on the acquisition and the level that we have with them. So that's in production right now, and because we now have that capability in-house, then we start looking at expanding it to the other use cases. So all of our solutions are decided based on the use case, not necessarily on the capability. So we do this, and we look at that, and we say, okay, now, can we use this for our offshore development centers? Can we use this for BYO? And those programs are in pilot right now, getting fairly close to decisions. For VDI, we do have a VDI environment up. It's all server hosted. We're delivering both applications and full desktops. So we've got it currently in pilot for BYO primary. BYO primary means that we're delivering the full desktop to that endpoint device. When we say primary, we mean we will take away your regular PC, and this is how you will work. So that's a tougher nut to crack than BYO Companion. So BYO Companion is really delivering the applications, Office and Internet Explorer and all those sorts of things, all our internal IE stuff. And one of the key things about this is that whether it's Companion, whether it's primary, whether we're doing streamed VDI or dedicated desktops, we still need to take the user data and put that in on a virtual drive. We need to put it in the cloud somewhere. And so that works great, and it's fairly easy to move that user's data up into the cloud. But one of the things that a lot of, I think, BYO programs don't think about until it's too late is offboarding. And this was one of the first areas where we started paying attention to offboarding of BYO. When you have a user who's leaving the company or no longer wants to do BYO or something, you got to think about how you get them off of that. They're not going to use necessarily that virtual drive anymore that we had for them in this virtualized environment. They want everything back on their C drive because they want to be mobile. And so we have to look at ways to get that sort of stuff going. So offboarding is definitely a challenge in a lot of these environments. In some of them where it's a type 2, it's fairly simple. You just take the thing. Yes?
How do you deal with things like shadow IT things, for example, where instead of using your virtual drive or whatever,
Well, there's really not much you can do other than give them a better solution. That's really the way that we approach it, and the way that we are approaching it, I should say. We haven't in the past, and it's a problem for us just like it's a problem for you. Dropbox is far too simple to use. What we want to do is we want to give them that capability internally where we know we can be safe, and let them use that. And maybe at zero cost, as opposed to where Dropbox, they have to pay for it. So it could be even a better solution, not just an equal solution. So that's kind of where we come to this. On our pathfinding plans, actually it's the next page, I'll talk about a little bit about what we're doing there. But for pathfinding, we are looking at a VDI client hosted that's called Back to My PC, and this is basically where a lot of people when they're at work, they have their PC, and then they want to go to a meeting. They don't want to take their PC, they don't want to hibernate it or shut it down or stand by or whatever. They want to just go off to their meeting, and they have an iPad. And so what we want to enable is the capability of just taking that iPad with you, connecting to your desktop back at your PC, and just bringing your iPad to your meeting and working off of that, even though you're still working on your PC. It's a fairly easy thing to do. You can get an RDP client for your iPad, no problem at all. We're trying to do it in such a way that it's managed and controlled, but also still easy for the user to do. In fact, easier than having to plug in your address, because RDP client works great unless DNS hasn't caught up to your machine name, because you're on a laptop and your IP address changes all the time. It is a problem. So the other area that we're looking is Type 1 hypervisor technology. We looked at this a year ago. We looked at it 2 years ago. The pathfinding team has been looking at it for a while. We all think that we're getting to a point where the capabilities are almost there. And so now we're launching a pathfinding to look at the Type 1 hypervisor solutions that are out there, and not just see if they're ready, but talk to the vendors and tell them what we need in order to be able to do this. They're getting close. So we're taking that fresh look at the current products, whether or not they can provide the better security and performance. Obviously, if we can get Type 1 to work, that would be wonderful for BYO especially. So the things that we're looking at are the enterprise-worthy management of the hypervisor. So we want to look at the the security, the encryption, and all that kind of stuff. Our security team loves to give us these challenges and make us work harder on that stuff. And of course, being able to do remote kill, remote wipe of those containers would be very good, and how we easily provision the VMs within those. We look at all that kind of stuff. We're looking at the performance, especially what it does to the battery life if you're running 2 VMs on it, how the system functions, how the graphics come through, things like VoIP and how that works based on how much disk I/O that you're seeing in the system and all that. So we look at all that, and then of course a big one is wireless LAN authentication. We have to have support for certificate-based wireless. If it can't get a certificate on it, then it's not going to get on our wireless system. It's as simple as that. And so we need to look at the capabilities that are out there to do that sorts of thing. And then another one that's interesting is whether or not they can do a P2V. One of the things about Type 1 hypervisor is that generally speaking, it is going to wipe out the existing operating system. Well, we want the ability to uplift that existing operating system, slide the hypervisor underneath it, and then add another operating system. If we can do something like that, then we can take a user's PC that they bring in, turn the operating system that's on there now into a virtual machine with a hypervisor underneath it, and then we can add the business VM on the other side of that. There's some stuff that's going on to actually make that capable in the very near future, but, and this is the big one, until we can do a V2P and put that machine back the way it was, it's going to be a very difficult thing for us to do, because again, that last day office, that offboarding, becomes a real challenge. You don't want to, you think it'd be very simple, right? You have a hypervisor, the user's got their VM on there. Well, you just wipe the corporate VM and they're good to go. Well, they're not really good to go. You still have a hypervisor. You're still using up a license for the hypervisor, very possibly. The user still has to deal with the hypervisor. They don't get their machine back the way that they brought it in. So you have to deal with those offboarding issues. And then we get to the technical evaluations. This is kind of the stuff that I'm involved in much more heavily right now. We're doing 2 areas. One is user virtualization. So the primary goal is we want to understand how the user works. We know that users don't log off and log on. They put it to sleep. They don't reboot. And so a lot of products that are out there depend on log on, log off to capture user settings, and so it doesn't really work. If users never do that, it never captures the settings. And so we have to look at tools that understand that and that maybe capture those settings when the application that they're working with exits and things like that. Our primary target is PC to PC transition. With 100,000+ laptops, we refresh a quarter of those every year, and then we have about another 15,000 break fix. So about 40,000 PCs a year go through a PC to PC transition. If we can figure out a way to do that better, we can save an awful lot of money with our PC techs. So we look at that. We also look at the virtual environments. So if we want to be able to stream VDI, which will scale better than personal VDI, we need to be able to deliver that user personalization to those desktops and do it well. And then, of course, we also need to define the applications that are going to be managed. We don't want to capture everything about every application that's on that device. We need to define those applications that we want to capture and be able to bring onto new devices. So that's all in progress. We've really completed the technical evaluations at this point. We're doing vendor selection. We're also looking at, as one alternative, being able to do something in-house, whether or not we can do something that's good enough without having to go to a vendor. We're doing that analysis as well. So hopefully by the end of this year, we will have something in place. And then the other big one, and this is a big one, and this is content synchronization, which is what he was talking about. We want to analyze the current offerings. There's a whole bunch of stuff that's coming up out there right now for content synchronization, especially internal cloud-based content sync. What we're talking about here is the ability to just have everything centrally stored, delivered to your endpoints in the way that's most appropriate for that endpoint. So for example, on my PC, I want all of my data, right? But on my Windows-based tablet, I might not want all my data. I might want to be able to pick and choose which data I want on that one because it's not going to have as much storage on it. On my iPhone, I certainly don't want all my data, but I want to see what's there and be able to cache what I want offline. So again, it's totally dependent on the device, and so you have to look at all those capabilities that these content synchronization products give you, and see if it works. Initially, we are targeting, again, PC to PC because that is our big hit, 40,000 machines a year. But we also want to replace the use of Dropbox-type solutions. We really are trying to get it so that we've got an internal solution that users can easily do, share a file and do all the things that you can do with Dropbox, but keep it internal and keep it from escaping. So we're doing all that, and one thing that's not on here is at the same time we want to evaluate the things like Dropbox and Box and all those, and make recommendations to the user for which ones they might want to use for their personal data. A lot of them really probably haven't thought about it to this point. And so as we move to this and we say, okay, we're not going to back up your personal data, we're not going to do anything with your personal data, so you need to think about what you're going to do with it and give them recommendations on what to do. Yeah?
But ultimately, the selection of whether I put a file in Dropbox or your personal thing is up to me, is that correct? There's no DLP system?
Correct. Yeah, that's correct. Ultimately, that decision comes to you, but what we're looking at doing is modifying the libraries so that, so the default that goes into our documents, obviously, your music files are going to be redirected to the personal folder, and your video files will be redirected to the personal folder. So we'll modify those, the library connections to assist the user in putting them in the right place. But yeah, ultimately, that's correct. So the technical evaluations are ongoing right now, and the vendor selection should be going on in this quarter, so we'll have that delivered by the end of the year as well. And these things, if you look at them, they're kind of separate, but they're very dependent on each other in order to deliver a full solution. So the way these timelines have worked out, they're kind of all together. The other one that's going on that is actually happening in another group is the idea of going to online archives. Exchange 2010 allows for online archives, and so we are looking to get enough storage to be able to take all the users' PSTs and put them online and have them available for them forever. It's a scary thought, but it's something we absolutely have to do in order to be able to do this, all this stuff we're trying to do. If that PST is still sitting on a hard drive somewhere, then none of this is going to work. So, quick summary, and then I will hand it off to Ryan. Embrace consumerization. Don't hide from it. We have to do that. Try to look for a consistent and optimized experience across different devices. So look at tools that work across multiple devices with similar interfaces, but that are optimized for that device. Virtualized containers that combine to form the workspace. That's our ultimate architectural direction. That's what we're spending all our time on these days. Abstract and virtualize the user state, the applications, the data, and the mail, and deliver those independently, consumed on the devices that they're best suited for. And then provide those IT services based on that dynamic trust level. So that's the end of what I want to talk about, and I will hand it off to you.
Thanks, Roy. So I'm going to switch gears here a little bit. Actually, the things that I do are look at basically every single desktop virtualization technology that's anybody in Intel is actually interested in. So I'm part of Intel Architecture Systems Integration and an emerging compute lab. All the products we have today, we haven't actually production implemented at Intel, but we do look at all of how everything runs, VDI, Type 1, Type 2, across the spectrum. Roy and I forgot to mention at the beginning, we do actually have some SSDs to give away at the end, so we'll have a question that you guys can text my phone, the first 2 people that can get the correct answer or give 240 gig SSDs. So I'm going to do, when I first got asked to come to BriForum, I thought what would be interesting for this audience that I've kind of been working on. So there's a feature that I'm not sure if you guys are aware of called local app support through VDI, which I'll be discussing briefly. Then we also have an E3 microserver for VHD. It's a reference design that's going to be coming out end of this quarter. It's basically it's like a remote FX workload, but showing that you can run remote FX workloads, common workloads, on integrated graphics cards on Blade server. And then we also have client-side performance testing here in VHD. Now this is actually in Login VSI's latest release that came out 2-3 months ago, and we have some initial data. So I'm going to throw a lot of graphs and things on the screen, try to explain through all of them as we go. So here's local app support. So this first came out with RES software a year or something ago, and you could basically have the ability to render a local application into a VM in one user workspace. So the user doesn't know that they're actually, when they click on the icon, they're actually executing these locally. So what I've done, this feature became available at the end of last year inside of Zoom Desktop 5.6. So anytime this user actually clicks on Communicator, Internet Explorer, or Skype, they actually run that application actually executes locally. So then we take a look at what that looks like over on the Zoom server host. So the top for the first one and the third one, that's when the user actually hasn't run this configuration. And they take a standard configuration of Win7 VM with 1 virtual CPU, 2 gigs of memory, and they're basically running at 100% CPU on the back end. And this is basically a business video conference session in Skype. One video looking at yourself, how you're presenting yourself to the video conference, and then the other 2 screens to people you're calling. But then when we do this through local app, you can see that the VM really is doing nothing there besides it's a 2% utilization, because it's really that application is executing local OS. And then anytime anybody out there decides that they want to put up something in humorous rebuttal to it. I'm not going to play it right now, but it's essentially a Ricky Gervais opening monologue of the Golden Globe Awards, the Charlie Sheen comments and all that. And it should, yeah, I've injected 150 milliseconds worth of latency in here, but it shows it for both, even with 150 milliseconds of latency, running VDI, it's monologues out of sync, it's bearable, but even with the flash optimization running, and then versus local. So, you know, move past that. I just want to make you aware that this is actually a feature that you can utilize, you know, balance between the server and the client. And then we've got here, this is something that Lenovo wanted us to do. So, if you go and you buy these clients, or thin clients, zero clients, Lenovo clients, they get shipped to you for a VDI POC. You're going to probably see some type of similar performance with this default configuration right out of the box. There's no customizations here. I know that if somebody told me to turn these green, I could probably turn these green, but it would take looking things up, firmware updates, right versions of it. So, has anyone seen one of these Lenovo M92 Tinies? It's the size of like 4 golf balls. It's actually smaller than this. And then we also have another reference design that we sell out of our channel group, which is the size of a hockey puck as well. But going through here, essentially, this client can do everything. It can do type 1, it can do type 2, you can get it with, you can get it without a hard drive. It'll run multimedia redirection, a 720p video, 1080p video flash, and it all runs really well. Now when you start going to some of these other clients, now Lenovo doesn't make thin clients, so they referred us to the vendor that when one of their customers asked for thin clients, so they ended up shipping us these. And they're all hooked up to Zen Desktop 5.6 or 6 out of the back end, various versions. But all running the same type of workload all through. So, and this is all in this link down here in the bottom, as well as a white paper on it. So now we take those same clients, and what we're going to do with the same clients is this is just dispelling the myth that thin clients actually save you on power, because our 3rd generation core systems actually consume less power than these 3 thin clients that they send us. So if the vertical axis here, we've got power in watts, just a client. Then we've got idle power, we just turn the thing on. But then there's something interesting happens with VDI connected here. Really, the thin clients all jump up about 5 watts. And this is just connecting to a VDI backend and just displaying the VM on the client. And then here is a logging BSI, medium workload running, you know, still similar power. But then in the end, we run a 720p video, we do multimedia redirection. So sure, it bumps up in power, but that's running 24 frames per second, the maximum you can get through a Zen desktop session. Whereas the other ones are really struggling to hit 18, 20 frames per second. But still viewable. And then the zero client looks like a slideshow with a 720p video running. So I'm going to switch gears. Okay, I'm going to do this 3 times really. I'm going to go from clients to servers, and then I'm going to go back to clients. So here is our E3 microserver for low-cost VHD deployments. So this is if you've decided to move forward with your VDI deployment. This is specific to remote FX and for our integrated graphics. So this is, we've heard a lot of talk about remote FX in the room, in other sessions. But this is essentially the old way of doing it. We take a 4U system, and I have this system, and I stack discrete graphics cards in it, and then I configure it with remote FX and I run workloads. But a typical office workload doesn't really need to, it needs less than 12 frames per second for a typical office workload. So what I end up doing here is with this E3 line, and the server line is not very much different than our client line. Our client line goes I3, I5, I7. Same thing with servers. We got E3, E5, E7, and then a million different SKUs of each one. But essentially what we've done here is we've taken this client type SKU, converted to the server blade, and now you can run 32 gigs of memory, you can have 2 gigs, almost 2 gigs of assignable graphics. sitting in here. And you can stack 12 of these blades through here. So then, why does that matter? Or does it actually, can the system on the right actually keep up with discrete graphics on the left? And my answer, or the answer to the test is we can't. So really how we've been measuring remote effects data is in frames per second delivered into each VM. So spend some time explaining this. So here is 0 to 12 frames per second in running a typical workload. Office login, DSID workload. By the way, this is a publicly available workload. You guys can all get this and run this through login DSI. And then on the x-axis, we have a number of VMs that we're scaling to. So the blue graph right here, this is our second generation core. We didn't release this product. Notice the slant. We're actually not keeping up with discrete graphics here in this. And then the green is actually the discrete graphics. But then, with our third generation core graphics, which is really the Ivy Bridge graphics, sitting in all the ultrabooks as well, you've got the 3 bars in the back, which are all cranking out what the script is requiring between 10 and 11 frames per second. And here I've got all the different configurations. I've got Windows 2008 delivering Win 7 VMs. I've got what's called Win 8 at the time, because we haven't got the official release yet, delivering Win 7 VMs, and then we actually Windows 2012 delivering Win 8 VMs running desktop office workload. No Metro inside of that one, and not yet. So this is why we're going to end up releasing this platform as reference designs, because we think we can keep up with discrete graphics, if not even beat them by 15 to 22% on common office user workloads. So, okay, fine, but why does that matter? Because it's going to save you a bunch of costs on the back end. So instead of grabbing a dual socket server, traditional dual socket server, and then stuffing it full of discrete graphics cards, now it's a stacked graph, so it's a little bit over exaggerated, but in general, you're going to get like 7x reduced power consumption from moving from that E5 with discrete cards into running a remote effects workload on integrated graphics. And then here, for your reference, this is a standard wall power meter, and I multiply it by 1 kilodollar per kilowatt, which is expensive, but you can multiply that by wherever your data center is power region. So if you're in New York, it's a third of that, but the ratio still stays the same, right? You're still going to save on power. Green line discrete, this is the platform we didn't release. Red line is the blade. And inside that, that's the entire OpenBSI medium workload going across there. Good.
How would this compare with your Xeon, previous generation Xeon processor?
So this is a Xeon processor that's actually in here. It's just called an E3 Xeon versus an E5 Xeon. So it's allowing you to access into the integrated graphics portion. E5s aren't, Xeons aren't going to, they don't have integrated graphics anymore. So that's a big difference. Okay? So here, somebody always sends me at least 2 or 3 times a year, hey, my passmark data is so much better or just as good inside my VM as it is local. Or somebody sent me a couple months ago saying, hey, this company is saying that they run just as good as an i5 with their remote effects VDI solution or whatever one it is at the time, whether it's Vue or this. And so I've kind of overlaid these lines. So this is, look at the system here. You can see if you took this and you just took this data, you go, yeah, it is. It's as good as an i5, maybe not quite as good as an i7. But really, it's not a very good comparison. It's isolating everything to just the VM. There's no account for the VM end-to-end time. There's no account for when that image leaves the server, when the client decodes, the receiver decodes the image, the user mouse clicks, any of that stuff. So we've been actively working with Login BSI to develop something called client-side performance testing. And so inside here, this is inside of their software. It does 3 different tests. The first one is typing 26 characters. So if we go, I'll set them up. First one was doing 26 characters and giving you a response time of those 26 characters from whatever client you want to install that software on. It's beta, so it only works on Windows right now. So you have that on Windows. So the test I'm going to show you next is running on Windows, thin client, and then it's also running on an i5 client. So then the second test is actually taking a hash value or a PKI signature and copying and pasting it. Essentially just showing a copy and paste of text. And then the third one is this color wheel here, where what it does through the course thing, it flashes this color wheel up several times and then actually takes a pixel from the left, right, or right bottom, 4 different pixels in here, and then it reports back to the system how long did it take that pixel to leave the server, how long did it take the server to render the image, how long did it take across the network, and how long did it get decoded on the client side and this and that. So this is they told me I had to put this line in here. This is still very beta. I actually would have liked to have shown their actual tool, just like Splunk gets up there, right, and shows their tool, but it's a little ugly, so I had to take the graphs out and put it inside of an Excel spreadsheet. So what this test is actually 11 VMs running, just like we had a couple slides back, but we'll take away 12 VMs running. But we took one of those VMs and we displayed it down to an actual physical client. And we ran the client-side performance test on there and ran through these different operations. And so the initial logging via site tool shows, so here's the thing. So this millisecond latency is pretty high here, right? And this is because I've actually have a video running on both these clients at the same time and then have their tool. So if you can take a thin client out of the box, you look at it, and you just run copy and paste, you just run typing of text, you're not going to see a whole lot of deviation here at all. Even flashing just a standard picture up and rotating. And it's fine, there's a lot of money to be made in thin clients, I guess. But once you start doing anything on the local endpoint device, you start executing local programs through local app support, which I showed you before, you start doing multimedia redirection, start doing collaboration, video, Skype, you're going to run into essentially an end-user computing problem where the deviation starts to, it can't handle it. Thin client processing just can't handle it. And so we start getting additional deviation here. And then I actually have this YouTube video up here as well that shows the actual test running.
Is that a typo? You got a period in YouTube.
Hey.
Isn't that their URL shortly?
It could be the URL shortly. So, anyhow, and that is essentially it for me. I mean, I have a slight summary here, but it's basically, with your higher end endpoints, you're given additional headroom to run anything you want to run with additional flexibility. Integrated graphics for a server is good for performance per watt, and then any of these tests can be replicated with OEM software and third-party applications. It'll take a long time to do and set up, but you can do this yourself. Okay. With that, do we have any questions for either Roy or myself?
So, based on the results that you have, you're showing that your i5 is going to be a better solution than a thin client?
Right. Depending on what you're doing with it.
Sorry, what was the question again?
He was asking, based on the results, is the i5 better than the thin client, correct? Right. And so yes, that's essentially what I'm showing. For the client side version. Yeah.
Your slides will they be with all the other forums?
Sure.
Mm-hmm.
My email address is somewhere baked in here. Fine.
Okay.
Roy, on your Mac, that you're moving from parallels to more local apps,
Mm-hmm.
something like Office, does the client buy that or does the company buy that?
The company buys that. And that may be different depending on your company and the agreements that you have with Microsoft for your software and all that. Yeah, back there.
Question for Roy. In terms of the trust model that we saw, and yet comments being made about local content being played locally, being offered, or having that local interaction, how does Intel approach the question of trust and still not separating the user performance? Or do they set the expectation that if they're going to use a device that's not trusted or least trusted, that there'll be a restriction in both the content that's delivered and maybe the ability in which it's delivered?
Yeah, that's really what happens is and we're struggling with all this as well. I mean, so for example, let's say that you're on a trusted device. You can say run your application natively on that device. You can maybe install it locally, or you can get it delivered by, AppV or something like that, and you can run that locally. What that does then is that leaves information in the local registry and information on the hard drive and stuff like that. We don't necessarily want that in some situations where we want more control. So in those situations, we may deliver that virtually through a XenApp type solution, because we know that there's absolutely nothing that is ever going to hit that client, and so there's no traces left on it or anything like that. So that's kind of how it works. Is that we're going to give you access to the best that we can give you based on your trust level. Trying to get that to all happen dynamically is still a work in progress, but that's kind of the way we look at it: is deliver the best that you can to the device, and in some situations the answer just may be no, you don't get access to that information or to that application.
And is it ultimately letting the user and subscriber then choose based off of their trust? I mean, it's something that's going to be public and intuitive to the consumer. They'll say, I want this device, and I understand the limitation with that choice.
Very much so. So, for example, we have applications that allow us to do all sorts of things internally. Intel has their own fleet of airplanes. We can book flights on them, and it's actually really cool. And there's an application that allows us to do that. If a user wants that application on their iPhone, then they have to have VPN. And it's certificate based, and they have to have all the security in place to make sure that anybody who's doing something like that is in a trusted environment. So they're willing to accept all of the things that go along with putting a mobile device management system on here, having to run VPN and those sorts of things in order to be able to get at something that requires that higher level of trust. So that's what you're doing, is you're putting things in place to raise the trust level of the device. Yeah?
What tools or software are you using to deliver corporate emails like your iPhones, part of your BYOD?
Well, one of the really fun things about Intel is we don't get to tell people what products we use. So I can't tell you. It's sometimes it can be frustrating because and in other times, if you get enough information about the capabilities that we're delivering, it's pretty easy to figure out who we're using. But we just aren't allowed to say who. Marketing people are different; they get all sorts of waivers. So if you go talk to the Intel guys out there about what they're doing, they have partnerships with lots of different companies. But what Intel IT uses, we can't really say.